If it's so nice outside, how come the bugs keep on wanting to go inside, right? Anyways. Let's go back real quick here. If I asked you for precision, like your own words, if you needed to like describe or define precision, what would you say? Smallest increment of a tool. Yeah, of a measuring device, yes. And uncertainty is always half of my precision, right? So we figure out the precision, it's half. Okay? All right. Put your knowledge to the test. So let's assume this is an AC. What is the precision? Hold on. I can do this. I know how to work a scale. What's the precision of this device right here? Can you see the units? It says ml. What's the precision of this? What's the smallest it can go up by? 1. So, right? So if this is a little heavier, right, sure, the number can be big, but it can only go up, the smallest it can go up by is 1 at a time. 1 milliliter at a time. I don't know why milliliter is even a thing. But anyways, so that's, what about, you've seen this guy before. What's the precision of this thing? Can you see it? That's all I can do there. There's a decimal right there. So if I give you this, the precision of this device, we're assuming it's going to be 0.1 of a degree Celsius. Okay, that's the smallest this thing can go up. It will not detect anything smaller than that. It can't. Okay. All right. Let's go to page 6 at the top here. The precision of this was 50. We don't go by the numbers. Listen carefully. Don't go by the numbers. You go by the markings. The numbers help you, but don't say precision is 100 here. You go from marking to marking, like how much does each mark go up by? And we determined that this is 50 milliliters. Which one is more precise? This one or the one that we did before? This one. Both are milliliters. Can you see that? Which one do you think is more precise? This one? You're correct. Why would you say that this one is more precise?
Because it only goes up by 10, not 100.
Exactly. Smaller increments make it more precise. Got it? The smaller, and this is a little harder maybe to wrap your head around, but yeah, going up by 10 makes it more precise than this one, which goes up by 50. It cannot detect small changes as well as the other one. Okay? Okay, that's a good one, because that comes up a lot on tests, on ACs, on exams. I ask you which one is more precise between these two things. Do the math, figure out the precision, and then answer based on your numbers, okay? What about this one here? I asked you to do this as homework. What would be the precision of this? It's very hard to see. And here's where I'm going to give you a shortcut, okay? You pick any two numbers. Let's say I pick the 30 here and the 20 there. And this is my high and this is my low. Okay? This is the shortcut. I'll give you the formula right here. You may add this to your study sheet, but to find the precision, if you have a diagram, okay, you go high minus low divided by the number of gaps. This works every time. This is a cheat, okay? Some of you won't bother with this. 99% of the time, you'll just kind of try mental math. You'll do trial and error, and you figure out what the precision is. But if you have a hard time, this is going to help you. So let's say we know already, what is it, 2 2, 4, 6, 8, 10. Yeah, it is 2. Because to go from 20 to 30, right, there's a difference of 10, and you go up by 5 steps. So each mark is 2. But if you didn't get that, you go 30 minus 20. Make sure that is in brackets. Okay? And then how many gaps are there? I'm going to use a color for this. 1, 2, 3, 4, 5. 5 gaps. It's hard to see. Anyways, that's the best I could do there. Let's try orange. Made it worse probably, but anyways, 5 gaps. Okay, so that is the 5 that I'm going to put here. 5 gaps. I'm going to highlight that. Okay, so this is a, you know what? I would say everybody should have this on their study sheet, because I can see them throwing one at you where it's not going to be very easy to just eyeball it. You know what I mean? Like to just guess it. So I would say have this on your study sheet just in case. Okay, so this would be 10 divided by 5, which is 2, and we are in what? Minutes, right? This is all stuff that I found around the house. Okay, so this is a timer on the oven. It goes to 60 minutes, right? But the precision of that is 2 minutes. So P is 2 minutes. The uncertainty is half of that. So it'd be plus or minus 2 divided by 2, which is plus or minus 1 minute. So there's your precision and uncertainty from a diagram. You're expected to know how to do that. And I can almost guarantee you that there will be some sort of picture, and they're going to ask you, hey, what's the precision of this thing? Or, listen carefully, they may not ask you for the precision. They may go straight to the uncertainty. You should know that precision is required, okay? Like you have to find the precision to find the uncertainty. But they may only ask for the uncertainty. Make sure you label it with a U, or you circle it. Make sure you answer the question, okay? All right, next, actual measurement here. We focus in on that last decimal, and we're assuming that whatever was used to measure this, I used a caliper actually. It died on me, I need a new battery. But this thing can be very precise, right? It can give me up to 3 decimals. So in this case, the precision is 0.00. When it comes to the 3rd decimal, you just introduce the 1 in there. Okay, that is the precision of this device that was used to measure that. The uncertainty is 0.001 divided by 2. That's 0.0005 millimeters, right? And go plus or minus just to be safe. So here's your precision. Here's your uncertainty. And moving forward, everything that we measure will have these two. Okay. Measuring cup, marked in 125 milliliter increments. There's that marked. All you need to do is take what they give you when it's a word problem, right? And they say, this is marked in whatever, that is your precision. Okay? And therefore the uncertainty is just half, plus or minus half of that. It's also known, called the margin of error. What is this? 62.5. 62.5 milliliters is my uncertainty. That is my precision. Okay. Okay, because here we have an actual measurement, listen to this part. This is the new part that I'm going to add today. You can state this measurement with its uncertainty. So we do all of this just to say 173.358, you can copy this, millimeters, plus or minus 0.0005 of a millimeter. This is what we call stating the measurement plus or minus its uncertainty. So you're saying, hey, this piece measures that, but I may be off by this much. That's what you're saying here. So if you don't mind also adding measurement plus or minus uncertainty. This is coming back later. I just thought I would already introduce this now, because that's what's coming after. Once you know how to find a precision and uncertainty, we actually use it in problems that you may encounter. Okay. Common mistake is that students put the precision back here. They're like, oh, precision plus or minus 0.001. That's incorrect. We use the uncertainty to tag along with the actual measurement. Okay? Keep going. I asked you to not do 7 for now. We're coming to that in a bit. Look at this, right? My kids were younger, Tylenol, liquid Tylenol all the time. So I was like, hey, this is perfect. This is a little cup that comes with the Tylenol. What's the precision on this one? From marking to marking, notice that each marking has a number, makes it a lot easier, but we're going up by 5 every time. So this is 5 milliliters is the precision, and therefore the uncertainty is 5 divided by 2, which is plus or minus 2.5. Quite frankly, once you have the precision, uncertainty is just a standard divided by 2 every time. This one is every marking has a unit, a number. It's a teaspoon. So in this case, it would be 1 teaspoon. And uncertainty would simply be half of that. So it'd be plus or minus 0.5 of a teaspoon. If you'd like to keep it as a fraction, you're more than welcome to do so. I think this one is unfair. This one. So just forget it. Like I do say omit the dot, just focus on the numbers. On the next one here, it was the oven as well, the little toaster oven, and I'm thinking it doesn't make sense. The dots are all over the place. There's no consistency here, so I will just say omit it. Like we'll just forget about it. If you did it, I appreciate that, but I'm not going to do that to you, and the province won't do that either. It will be consistent. There's a clock here somewhere. The last exam had a clock, and students didn't know what to do with it. Here. Let's go to page 9 at the bottom of 9. What's the precision of this clock? 5 minutes. Because obviously the hour arm, we would not, that's not the smallest increment anyway, so forget about the hour. You look at the minute, right? The minute arm, and we can only go 5 minutes at a time. Exactly. So it's going to be plus 5. Plus 5, it's always 5, so it's 5 minutes. Was this on the key? I don't think so. I think I just introduced this after the exam. I added this picture there. Can I add one here? I'm just trying to see what they could do. What if you had one like that? And all you had is this small hour. What's the precision here? Minutes you can't count. The hour arm is there. You can only do 3-hour increments, right? So the precision here is 3 hours. So therefore the uncertainty is plus or minus 1.5 of an hour. So try to think what's the smallest increment. In this case, there's only one of the arms, the hour one, right? And so it's only 3-hour increments that you can do. So I don't know what they're coming up with this time, but just be careful and just think about it. It's usually only, if it's just precision, it's a 1-mark question. What about the, this is my barbecue outside, right here. It's all fogged up already. Anybody figure out the, oh, it's not very good. Focus. Like, well, it's blurry. There you go, that's not bad. So this would probably be I don't know if you needed that formula, but if I make that the high, and this one the low, Mrs. Erickson, does it matter which two numbers? Can I pick this one and can I pick that one? Yes, you can pick any two, but then you have more gaps to count, right? That's the only thing. So I try to pick the numbers that are close to each other. So in this case, I would go 700 minus 600, and then count how many? 1, 2, 3, 4. So you don't count where you're at. You count as soon as you start walking, right? 1, 2, 3, 4. 4 gaps. So you divide this by 4. So this is 100 divided by 4, which would be 25. And did you catch the units? They're right here, degrees Fahrenheit. So this is Fahrenheit. Oh, you can't see that, sorry. So uncertainty is 25 divided by 2, which is plus or minus 12.5 degrees Fahrenheit. So, I want to keep going. I don't know if you finished this whole thing. Did you go all the way to 16? Or do you need a bit of class time to do it? You know what? I'm going to give you a little bit of class time to do it. Especially, okay, when it comes to the rulers back here, when it comes to inches. I'm not sure if you're going to be all right with that, but I'm going to have to maybe review that in a bit. But I'm going to ask you to go all the way to 16. Hold it. Stop at 14. I think that's what I said. Stop at 14. The key is online. I'm going to just come around and check, making sure you're all right. If you're done already, you can go to page 7 and try to read that question, and I'm very sure you can answer it at this point. Okay. So if you're done everything, go to 7. If not, work all the way to page 14. For every question, you figure out what the precision is and what the uncertainty is. All right? Make sure you try it. So good work. So I think you need to have this on your study sheet, in my opinion. If they ask you which one is more precise, the answer is the smallest precision tells you which item is more precise. Which this is on page 7. Okay, the smallest precision. So I'm just going to give you some easy examples where you could tell right away. If you have 0.0, actually this is a good one. I'm just going to keep it like that. Versus 0.1, 4. Let's do 4.1. If I asked you between these two, which one is more precise? Which device is more precise? Which one would you go for?
The first one.
This one. Because the precision, right, if the units are the same, we're looking at like the most amount of decimals is more precise. Because the more decimals you have, the smaller your precision is. So this one wins the battle here. So don't go by the actual measurement, you go by the precision, okay? Can you wrap your head around that? Okay. Let's keep going here. So there was something similar to this a couple years ago. So you have 3 beakers and they're asking you, hey, show some work and tell me which one is more precise. So I'll go with this one first. I'm just going to go with my cheat, okay? This is I'm going to call this my high, and this is the low. So it's going to be 100 minus 50, and then I'm just going to go 1, 2 gaps, right? So that'd be 50 divided by 2. Please do not mistake this with uncertainty. Some students see this like, oh, this is just like my uncertainty. It's always divided by 2. It is not always divided by 2. It's just this number, the gaps happen to be 2. Okay, so that will give me 25 mLs for this one. And the uncertainty, this is just added practice. Technically, we didn't need to answer the uncertainty to answer this question. Okay, guys? But this will be 25 divided by 2. That's plus or minus 12.5 mLs. Then we go to the bigger one here. Do not let the size of the beaker throw you off. You do the math, you do whatever it takes, and that's what you base your decision on. In this case, this is my high, this is my low. Okay, where am I going to do the work here? I'm going to do this right here in the beaker. So this would be 500 minus 250. Make sure you put that in brackets. And then you count. There's also going to be 2 gaps here. So it's going to be divided by 2 as well. 250 divided by 2, that's 125. So it's a little messy. I apologize for that, but the precision here is 125. Uncertainty is 125 divided by 2. I need my key. That's 62.5. I knew that. Anyways, plus or minus. So far, this one is winning, right? This one is winning. This is more precise comparison. Next, you have your high and your low here. So to do your precision, I would go 60 minus 20, and then count. 1, 2, 3, 4 gaps. So I divide this by 4. So this is 40 divided by 4, which is 10, right? I get quite creative when I make my beakers, so watch out. Okay, just follow this and you should be fine. So this is 10 milliliters, and this will be plus or minus 5 milliliters. It's probably a good idea to look for the units. They all happen to have the same units, so we're good. If one of them had liters and the other one had milliliters, you would go with the milliliters, right? They're more, that one is more precise. So you gotta watch out. So in this case, we're gonna make clear that whoever's marking this knows that this one is more precise. Okay. So that's how you do that. Between Vancouver, Winnipeg, and Hudson Bay, so there's 3 cities with temperatures. Which one of these is most precise? All Celsius, right? So that's not a problem. This will be 1. This is 1 Celsius. Okay. This one is 0.01. It's right there, second decimal place. And this one only has 1 decimal place. So this is 0.1 degrees Celsius. We're not going to do the uncertainty now, okay? That I think you got it. So Winnipeg, right? This temperature right here, whatever was used to measure Winnipeg's temperature, is most precise. So I would say if it's decimals that we're looking for, you're looking for the most amount of decimals, okay? Then boom, that's the one. If it's a picture, you got to do a little bit of work there to figure that out. Okay, I will say this. Do you want more? I'm glad you asked. 16. I'm not going to give you time right now. I'd rather give you some later on if need be. 15 and 16. So pages 15 and 16 has this type of scenarios. Okay, if you want more, on which one is more precise, go to 15 and 16, and that's where you can get some practice there. Ruler, measuring tape. You need to know how to do that. Let's go to 14. I introduced that there. All of these are, this one is in inches. What's my precision there? You just count from 1 inch to another inch. Just count how many marks there are. 1, 2, 3. This is 4 to the middle. So it's going to be another 4, right? 1, 2. So there's 8. So the precision of this is 1/8 of an inch. Okay? If you don't like that as a fraction, just turn it into a decimal. That's okay. And what's the uncertainty? It'll be 0.125 divided by 2. Which is 0.0625. Do not round in this unit, okay? That's the safest thing to do. What would the uncertainty have been as a fraction? Remember I told you yesterday, 1/8 turns into 1/16, right? You basically double the denominator. You're slicing the 8 into half, right? Like all these gaps, essentially you're slicing them in half. You're adding a mark in between every existing mark. So now you have 1/16 of an inch. So if you rather do that, you're fine, okay? But most of us do not like fractions, so we're going to turn it into a decimal and then get our uncertainty that way. Okay. What about this one? Precision here. I know that, Adrian, you brought it up. There's feet here. It's because every measuring tape, I was just checking, it has at the beginning, has the feet and inches, but the feet won't show up until later, right? 1 foot, right? So this is, I'm just taking a picture of this little piece here. So ignore the foot there. Okay, you can ignore that. Just count from 1 inch to another. There's 1, 2, I'm going to count from inside. 1, 2, 3, 4, 5, 6, 7, 8. That gets you to the middle. So you know it's going to be another 8. 9, 10, 11, 12, 13, 14, 15, 16. There's 16 gaps. Okay, so in this case, when it's a imperial ruler, you just say it's 1/16 of an inch. So count. It could be a quarter, it could be quarter of an inch, 1/8 of an inch. It depends. This turns out to be 0.0625. We already knew that from up here. Our uncertainty used to be that. For this ruler, or measuring tape, we need to split this in half to get our uncertainty, which is 0.03125 of an inch. What would it be as a fraction? 1/32 of an inch, right? You basically double that. That's how fractions work. If you half it, you actually double the denominator. Okay, so please get the ruler, get the measuring tapes right. It shouldn't be that hard. From time to time, they do show up. Don't do this, right? But I will show you something else they could do. I'm going to use whiteout here. Let's just zoom in. Let's just zoom into this part right here. What if this ruler had, oh man, I got the 6. The 6 is gone. If I just zoomed into this, so let's pretend this whole ruler just had 5, 6, 7, 8. What would the precision be in that case? Just 1 inch. Okay. So they're going to try to see, do you understand what's happening here? Are you just copying what your teacher did, right? They don't want that. They don't like you to just be robots, right? Be warned. Okay, I'm going to stop here. Now we're